at this point, tension. So tension is actually, as I told you, that it is a reaction force, and it is not normal reaction force. Normal reaction force means the force which works as a contact of the surface. For example, if you have an object placed on the surface, and then it will have a downward force, let's say its weight, and as a result there will be a normal reaction force. This is not tension actually. A tension is not that. So I believe that you will be able to make it clear. It is, it appears when a spring or a string is stretched, right? So when you are going to stretch a string, or when you are going to stretch a spring, then what do you have? You will have a force of tension there. Let's say this is the normal spring, it has no tension. Okay, it does not have any tension. But when you are going to attach some load with that, what will happen? It will be stretched, and when it will be stretched, actually you will say that okay, now weight is attached, and then there is a tension in this string, right, in that spring. So this is actually the game of the weight. Okay, so when we say that the object is in equilibrium, then the situation is a bit different, right? In equilibrium, equilibrium means two things: either bodies at rest, okay, or moving with what? Constant speed. Okay, constant, rather you can say constant velocity. So if this is happening, then you can simply say that the object will have or the object is in equilibrium. When an object is in equilibrium, tension will be equal to weight. I mean, I was just explaining the concept of weight. So there, the tension is equals to weight of the object. So you can simply say that if that tension is in the string, then in the string that tension is equals to mg, but in the spring tension is equals to, yes, in spring tension is equals to weight, but that tension is equals to k times extension. We will talk about this topic in future, inshallah, deformation chapter. This is you people have learned about k times x, or you can simply say kx is equals to weight. So these are two concepts what you have to master when you are talking about the tension. Then there are some other aspects also, and those are related with accelerated motion, what we will talk about today. That in case of accelerated motion, what do these objects have in case of accelerated motion? Yeah, did you notice what I complained with you? They have written on my screen a lot, and they have changed the colors of the ink as well. So in case of accelerated motion, you know what happens? Net force is equals to what? Net force, a resultant force, is driving force minus resistive force or opposing force. Are you getting it? Okay, is it clear to you?
Yes.
Okay,
Yes.
so if I say that here the driving force is, let's say, weight force, in this case of this row, if this is the driving force, is the weight force, then opposing force can be the tension. So you can simply say that if the object is accelerating downward, if acceleration is downward, then definitely the weight must be greater than tension, and your F net will be equals to weight minus tension, which shows that MA is equals to mg minus T. And in this case, you can find the tension, like tension on the string is mg minus Ma. Right? Will you be able to remember this setup? Yes? Do you hear me?
Yes.
Okay. So in this situation, this is
Mhm.
actually the concept of tension. But
We
if
reached further math.
yes, in your further math it was. So tension will be zero if A is equals to G. It's very interesting factor. That is actually when we say that what is tension, so that tension means we have a meter here which reads the tension, right? This is the force, so that reads the tension. दरवाजा बंद करके जाना, ठीक है? So if the body is accelerating, this is its weight and it is its tension. So that tension will be appearing here. Okay. So sometimes this tension is called apparent weight. Sometimes what do we do, or what do we call it? It is your apparent weight. Right. What is that? Apparent weight. Right. For example, if you are going to measure the weight of this object with the help of a Newton meter, so what do you say? What do you have? I mean, what I'm talking to you, that is, it is apparent weight. For example, it is a Newton meter, and with the help of that Newton meter, you are hanging a load, like,
Onu nerede bir saniye? Bir saniye.
isn't it?
Ben gelen böyle.
This way.
Ha? Ben
So
gelen
what will happen?
bu ne o?
This
Şuradan
will tell
ben
you
məktəb başlayanı. Bu senin şu sövdə işləyəsən. Məktəb başlayanı bir
all
də
these values. Is it? So it will give you a proper number. For example, it is going to give you this reading. This is the pointer, isn't it? Are you getting it?
yes.
So what does it mean? That this is actually the weight, and weight is mentioned by this reading. So isn't it apparent weight?
Yes. Abi
So actually apparent weight either appears due to tension on the spring or tension on the string. Got it? Equals to tension. So apparent weight will be equal to zero. Apparent weight will be equal to zero if tension equal to zero. And when tension will be equal to zero? Yes. If in this equation acceleration becomes equal to a, sorry, acceleration becomes equal to g, this a becomes equal to g, then your object will have zero acceleration, zero tension rather. Right? Is it clear to you? Yeah, yeah. Do you hear me? Yeah, yeah. Do you hear me? Hello.
So just a second, please.
Okay, okay, okay. Sorry, it's fine. I was thinking that you left.
Yaxşı oxşur deyirəm mən. Sir, yes, we can continue.
Yes, are you back?
Yes.
Okay. So there was another case. In that case, most of the time, you have the tension on the inclined plane. For example, if I have a block and there is a motor or a pulley attached with this inclined plane at this position, and there is a rope attached to this pulley, okay, and that is providing a force in the upward direction. Okay, are you getting this setup?
Yes.
Okay, so the weight of this rod will be, sorry, weight of this block will be exactly downward, isn't it? And there will be a normal reaction force in this direction. This is a normal reaction force. And what about the component of the weight? The weight is resolved into two components. This is its mg cos theta, and this one is its mg sine theta. Okay, you got it?
Yes.
Okay, this is mg sine theta. So if I just change its color, this is the blue one. So that is your mg sine theta. Okay, so just see that if the body is in equilibrium, what about tension and weight?
Tension
Tension
is
is equal
equal
to,
to mg sin theta.
yes, because here is no friction, no friction. That's why. If there would be friction, then definitely we have to mention it. And in this case, it will be simple. The tension will be equals to mg sine theta. Now, in case of friction, if I draw this diagram again for you, and you can just see that if there is a friction and body is accelerating or moving upward, moving up the slope with constant velocity or with acceleration is equals to zero. So again, if you see that there is a tension on this rope, okay, this is a rope and there is a tension on this, and then friction will be in this direction, isn't it? Here will be friction. And if you say that weight will be downward, it will be mg, and I'm going to resolve the weight into its components. One is it's mg sine theta, and what about this one? Sorry, the upper one is mg cos theta. This one is mg sine theta. This one is mg sine theta. And what about the upper one? I mean this component. This is not mg cos sine. This is actually your mg cos theta. So I'm just writing it in this way. It is your mg cos theta. So how to handle the tension right here? Yes, here
Yeah.
your tension is equals to mg sine theta plus friction. Is it clear to you? Yes, yeah, yeah. Is it clear to you?
Yes.
Okay. Now, in the same way, we have different situations. These are actually all the questions that what I have considered here. These all are the past paper questions in different forms. That if a body is again here, oh, if a body is here, and that body has a force in such a way that its tension is upward, there is that is attached with the rope, and it is accelerating downward, accelerating down the slope, right? So when it is accelerating down, friction will be here. Just a second. My laptop wants to take a reset. Is my screen disappeared? Yes, yeah, yeah.
Yes.
Yeah.
Hello.
So yeah, I was saying that if the body is having acceleration downward, so in downward acceleration, do you know what will happen? Where would be the friction?
Upwards because it's downward
Yes.
acceleration.
So that is the friction. And if I say that um, the weight force will be resolved into components, and those components will be, this is its weight, mg, right? And this will be its mg cos theta, and this is its mg sine theta. Okay, so mg sine theta. So again, if it is accelerating downward for this block, what is the driving force then? Your mg sine theta is the driving force. Then what are the opposing forces? Minus tension plus friction. Are you getting it?
Yes.
So from here, your tension will be equals to mg sine theta. Sorry, friction minus, because I have put the signs correctly. So you can just make this equation after one more step. Mg sine theta minus t. This all will be equal to 0, right? Minus t minus friction, right, equal to 0. Either you can write the equation in this format, or in the other way around, what I have taught you, that here mg sine theta is equals to tension plus friction. So from here, your tension will be equal to mg sine theta minus friction. Is it clear to you? So you must be aware of the situation, that in which situation we are having the tension and how to handle that. Then there's a combination of upthrust and tension. Upthrust and tension. These all are the cases actually in your past papers. So when we are talking about upthrust and tension, first of all, if we have upthrust acting on a ball or acting on a body. Let's say this is the surface of a liquid, right? It is a liquid surface, and there is an object below the surface of the liquid, like here, okay? And there is a rope attached with that, okay? This is what? This is the rope.
Yes.
Or it is attached with a motor, let's say. You can simply say okay, a motor is driving it upward or motor is dragging it up. Then here its weight is downward, okay? Up thrust is here, upward. Viscous drag is downward, right? And tension is upward. So this is the combination of the forces what you can imagine here, that for equilibrium, what will happen? You will see that up thrust plus tension, that is equals to weight plus viscous drag. Right? Is it clear to you? Okay. This object will have the same up thrust or same tension until this point. Let's say it is reached to the surface of the liquid here. Okay, surface of the liquid. It is till this point, everything will be same, right? It is the tension on the rope in the upward direction, weight will be downward, up thrust will be upward, and viscous drag will be downward. So this is the same situation, right? Are you getting my point? From bottom to the top of the surface of the liquid, right? This all happens till this point. From bottom of the surface or from any position to the top of liquid surface. This will be the situation throughout. But when the object will be immersed, I mean, object will be drained out of the water, liquid surface, then what will happen to that? That's this is a liquid surface. And you have just made this object halfway up and halfway down. Here, what do you expect? What forces will change? Its weight will remain same, is it? Are you there?
Yes. Yes.
Up thrust,
Finished.
although it is in the upward direction, but up thrust decreased, is it? And drag is also decreased. Very interesting point. Drag decreased because it's some of the area is in air and some of the area is in now liquid. So drag decreased, drag force decreased. Now the formation is, if you are applying the same tension for same tension. So okay, wait. First of all, I will ask you that whether tension of that object will be reduced or not. Motor tension on the motor or tension on the string will reduce or not. What about this tension? Yes. Are you there? Tension is increased because upthrust is decreased. This is very interesting thing because upthrust decreased. Yeah, yeah. Do you hear me?
Yes.
Right. So is this point clear to you? Tension is increased because that force which was pulling it upward, it has been reduced. So that force is reduced now. So here I can just uh, show it in terms of vectors. Let's say this was the upthrust. It is same here, and here it has been reduced. So here, if same tension is or same force is applied by the driving agent, what will happen? Yes, yeah, yeah.
Yes, sir.
If the driving agent is applying the same force, then what will happen?
So can you repeat the question?
My question is, in this case, if the driving agent is reducing the speed force, then what will happen?
Well, there's deceleration. If it's reducing the speed,
Reducing the speed, nahi.
you say it's
Sorry.
reducing the speed.
No, no, reducing the driving tension, driving force, you can say.
Oh, if it is decreasing the driving force,
Yeah, actually, this is the motor, na? This is the motor.
yes.
So if the motor is meant, if the motor has the same force applied in the upward direction as it was here, or here, then what do you think? What will happen?
Um, we
Will
go
this
up,
object be? Will this object will move up or it will sink down?
so go up,
Hmm?
it will move up.
It will not move up because
So,
let's say, let me explain it. If in this situation here the object is here and then object was here under the water. Okay, that is underwater, and here it is partially above the water. Hmm? I'm going to put the values here. Let's say its weight was 50 Newton, right? The viscous drag was, let's say, 20 Newton, and upthrust is the biggest force here. So let's say upthrust is this is the drag, okay? Then this is the weight. Then upthrust is, let's say, 40 Newton, right? So what tension is required to pull it up at a constant speed? Isn't it 30 Newton? Because 30 plus 40, answer is 70. Upthrust is supporting tension, Okay, and this is basically drag plus weight, that is 20 plus 50, that is 70 Newton. Right? Did you get it? But as the object is moving up, then what happens?
Uh,
Just a second. Okay, at this position, what will happen? I was actually uh, making this at a higher position so that I can write something about that. Weight is same here. Weight is same. Weight does not change. So your weight is 50 Newton. Up, I mean, drag is reduced. Let's say the drag is now 10 Newton or 15 Newton because it will not that much reduced. Because if the object is moving with the same speed in the upward constant speed, then it must have final the same value. What about the drag force? Sorry, upward, upthrust. Upthrust will be reduced drastically. So it would be left now 20 Newton because half of the object is above and half of the object is below. Are you getting it? Now how much tension do I need? Again, tension plus upthrust is equals to drag plus weight. So tension plus 20 is equals to 15 plus 50. So that is your 65 minus 20. So your tension will be 45 Newton. Are you getting my point?
yes.
So when we just pull the objects out of the water, the rope has to apply more force, or there is a more taut or the force appear on the weight, appear on the rope. You know why? Because that rope was supported. I mean, the tension was supported by upthrust, but when that upthrust is removed, right, upward force is removed, then there will be more force. And finally, when the object is fully out of water or fully out of liquid, then the highest tension will be at what point? When the object is out of water. Here. You know why? Weight is still 50. If it is moving with a constant speed, if it is moving with the same constant speed, drag will be same. Now upthrust is zero. How much force this rope should apply now? This motor. Yes. Tension plus upthrust is equals to 50 plus 15. So your upthrust is zero. So entire tension is how much? 65 Newton. Is this point clear to you? Yeah, yeah.
Yes, sir.
Is it clear to you?
Yes, clear.
Okay. So in this way, we have completed all the area of types of forces: upthrust, tension, viscous drag, and everything. I hope that you will not have any query in that one.
No, no problem.
Not at all. Okay.